update. During today's webinar, we will review the trends and impacts of Power over Ethernet standards, including a discussion of how PoE impacts cabling performance, recent revisions to the National Electric Code, and a new UL designation for PoE cabling. Before we get into the webinar, I have just a few housekeeping things to take care of. First, today's webinar has been approved for BICC continuing education credits for those of you who are attending the live presentation. If you want to receive the BICC CECs, at the end of the presentation, a survey will pop up before we get into the Q&A, and you'll simply fill in your email address in the first survey question to receive the continuing education credits. And of course, we would invite you to complete the remainder of the survey as well. Also, all audience members have been muted. If you have questions during the session, please submit your questions through the console on your screen. We'll get to as many of the questions as we can at the end of the presentation. And finally, also in that console is a section marked Handouts. You will find in that section a copy of the slides, as well as several white papers related to Power over Ethernet. We invite you to download and review those documents for additional information. So to get started, I'm pleased to introduce our speaker for today, Frank Straka. Frank is the product line manager for copper cabling at Panduit. Frank is active in the TIA TR 42.7 standards group, which is developing the new standards to support applications like 100-watt PoE++ and 25 and 40 G-base-T. Frank holds 21 patents in copper connectivity and cable design, and he is a frequent speaker on new copper developments at conferences such as BICC, IWCS, and the Ethernet Summit. And with that, I will turn it over to Frank.
Thank you, Sandy. And thank you to everyone who's called in to take time out of your day to listen to me talk about Power over Ethernet. As we all know, Power over Ethernet is a hot topic, no pun intended. It is really being viewed as, in large ways, supporting the future of copper, enabling a lot of new technologies to be connected, particularly with these higher wattage standards. But because of these higher wattages, they actually do have an impact on the structured cabling involved. From both the performance side, which TIA is concerned about, and then there's also the National Electric Code, which takes a different look at it. So what I'm here today to do is provide an update, trying to do my best to reconcile both for everyone calling in, provide some guidance as Panduit sees it, and then hopefully can answer any questions you guys may have. So with that, let's get started. So what's driving the interest in Power over Ethernet over cable? It's partly because the new standard is dramatically increasing power. And with that, there's new code being developed by the NFPA with the National Electric Code. This code has in turn created a new UL listing that also affects it. On top of that all, there's a new standard out, or not a standard, but a technical service bulletin written by TIA that discusses much more on performance. So, really the question is what do you need to know and what should you do? So here are the general topics we're going to discuss. So the first thing is just to review this new Power over Ethernet standard. So what is PoE? It's data and power over a single cable, and this cable can be 5E, 6, or 6A. There's a few types of terminology commonly used. Power sourcing equipment, or PSE. It's a device that delivers or sources power over twisted pair cable, like a switch. There's also what's called a power device. This is the thing that takes power. Like, for example, the teleconference device I'm using to talk to you on. It takes a single cable, and that would be a PD. Then there's also end spans, which is a type of PSE that's located at the end of a channel, which would be a switch. Well, there's a mid-span, which is a PSA located between the two. So those are commonly known as PoE injectors, and that would be commonly, a lot of times they're black, they plug into the wall, and you plug in, your internet connection on one end, and out of the other side, you still have your internet connection, but then it also adds power to it. So how does it work? Well, here's a diagram on top, and you can see that the top pins 1, 2, and 3, 6 are connected to Power over Ethernet. This means that only 2 out of the 4 pairs currently get used today to provide the PoE+. PoE today also has a max speed of gigabit or 1,000 base T, and it only uses up to 600 milliamps per pair. All this adds up, so on the source side at the PSE, there's a max power of about 30 watts, and at the PD, there's a max power of about 25.5 watts. This is good for running stuff like IP phones, some security cameras, some access points. Where is it going? Now you see on this new image I have, all 4 pairs are now energized. So now we're talking about power on 4 out of the 4 pairs. This new PoE is commonly referred to as PoE++. I've also seen 4-pair PoE or 4P PoE used. This now has up to about 1 amp per pair and now has a max power of 99.9 watts on the source side, which offers power at the device of about 71 watts. So about a factor of a 3 increase on the power you're able to use for your devices. So breaking it all down into a simple table here for everyone to see. And what's highlighted in green is where we are going. So you can see now with this new standard, it really is a big change in where we're going with this. We're expecting to see ratification of the standard in Q1 of 2018. Now I will note that there are other things out there that are not standard based. For example, Cisco has a UPoE system that provides similar power levels to the Type 3 where the PoE is going. And then HD-based-T also offers something, I think it's called Power over HD-based-T or POH, that looks to be similar to the Type 4 being proposed. So there are other elements that are out there. What I really plan on focusing on today is the 2 standards, Type 3 and Type 4, that are being standardized. So this is the graph that really, why are we so interested in this, right? Is the application space is dramatically increasing. So today, you have some devices, some elements that can use it, say in an enterprise deployment. Where it's going is the vast majority of things in your enterprise can now be powered over Power over Ethernet. The real interesting ones for a lot of people are wireless devices. With this 2.11 AC and the new waves that are coming out, those are going to take a lot more power, and this can really power it. In addition to televisions, a lot of televisions these days could operate within that 71 watt limit, provided they're of the right type. So just a lot of excitement over this. There's a lot of interest in what it can do. So in summary, the new PoE standard, it uses 4 out of the 4 pairs, up to 71 watts to end devices, up to 10 G-base-T on data, and it's commonly called PoE++ or 4-pair PoE. So the next thing I'm going to talk about is the impact of PoE on cabling performance. So cabling, these are just frequently asked questions and talks I've done on PoE. So what are the cabling requirements for PoE? For the new standard, all it requires is 4-pair category 5E or higher. Another question I get asked, will the device get the power it needs regardless of cable length? And what this is trying to say is, well, this device needs, 71 watts of power. So do I need to be aware how long my channel is? Do I need to do anything special to make sure it works? And the answer to that is, no, you don't need to do anything special. The device is going to get the power it needs as long as it's a standards compliant channel. So that means category 5E, category 6, category 6A at 100 meters or less, it gets everything it needs. You do not need to do anything special. And is there a difference between the categories? The answer to that is also yes. PoE++ will run on Cat 5E and higher cabling. However, category 6A provides the best thermals and best power efficiency. These are an example of some of the standards used for PoE. So the top one is IEEE. That's sort of the umbrella standard, right? That's when you have the equipment guys get together with the chip guys, get together with the cabling guys, and we all talk about what's needed for PoE systems at a high level. That then goes to TIA to come up with more detailed cabling standards. And that's where I spend a lot of my time. So there's a TSB 184A. It's a TSB on guidelines for supporting power delivery over balanced twisted pair cablings. Discusses a lot of heat rise. And then there's also the ANSI TIA 568C.2 standard, which many people should be familiar with. That's the standard that really gives performance requirements for, say, Cat 5e, 6, and 6a. And there's also an IEC standard on connectivity with engaging and disengaging PoE. ISO IEC also have information on PoE, but for today's call, I will not be discussing those details. But they are similar to what we've seen in the U.S. So what is TSB 184A doing? Well, TSB 184 has always, or has not always, but it's been around for a long time, and discussed the impact of PoE and PoE Plus on cabling. It's now been updated for the new standards for these higher wattages. And you can see the picture on the right really shows what an example of that test would be. It's about 2 meters or so of cable put together between those two different objects. And you can see here we're injecting current on all 4 pairs to correspond to the different power levels, the Type 3 and Type 4 power levels. We make these cable bundles different size, so different amount of cables in each bundle. And we have thermocouples in the center of those cables to see how hot the cables get. So the recommendation per that standard is to really limit temperature rise to less than 15 degrees Celsius above the ambient temperature. What that ensures is that, if you have a temperature rise can lead to signal degradation, which means more insertion loss or attenuation on your system, which in turn limits how far it can go. And temperature rise can also cause long-term damage to the cable if it exceeds the rating, which that is uncommon. This shows actual results from testing we have done here at Panduit. So on the graph, the y-axis shows temperature rise above ambient. The x-axis shows the amount of current that's been injected on those wires. So, you see it's 350, 600, and about 1,000 milliamps are the different levels where we have data points. And the different lines refer to different cable types. So the red and purple lines refer to 28 gauge cables. The other 3 lines are different ones. The green is Panduit's Category 6A 26 gauge solution, so we call that SD cables. The brown line, or the gray line, is a Category 6 23 gauge, and the blue line is our Category 6A 23 gauge matrix system. You can see here there's a few observations you can draw from it. First of all, on the 28 gauge side. 28 gauge side, and this is for a 100 cable bundle, it does get hot, but 28 gauge absolutely can support PoE. There's no issues with running these higher power levels over a 28 gauge system. You just have to be more aware of the bundle size. So Panduit has a lot of guidance out there, but the first observation you can make is that 28 gauge cables absolutely supports PoE. The second observation here is that Category 6A has the best performance. You can see here that all the other cable types for 100 cable bundles are over that 15-degree temperature rise. However, Category 6A with the matrix is significantly under it. So, what we are really telling people about it is that cables like Panduit's Category 6A are recommended for PoE due to the optimal thermal performance of those cables. This is now taken out of the TSB 184A draft, and it's the max bundle sizes for 15 degrees C temperature rises. You can see this looks at a variety of different cable types. So, all the way from 26 gauge up to Category 8, and it's looking in 2 different environments, in air and conduit. So the rule of thumb we'll give you here is that if you don't have any additional guidance from the vendors you're using, these are good numbers to go with for what people recommend. But we will say the values shown here are conservative. Per our own internal testing, especially with Category 6A, we can greatly exceed those. And with 26 gauge as well, if you use Panduit's SD solution. This standard, again, everyone's probably familiar with this. This is when if you go to test your system and it shows a pass, it meets Category 6 or Category 6A, it passed this standard. It provides performance requirements for different categories. But one thing that a lot of people don't know about it is it provides guidance on the effect of heat on cable insertion loss. So for a variety of temperatures you may see, this provides information on what those different temperatures will do to your cabling's performance. Here is a table taken, copied out of that document. And what this table shows is the effect of heat on channel length. And so it's given in either Celsius or Fahrenheit. And what it's really saying is that at room temperature, 90 meters works. You have no issues with a 90-meter link. This does not take into account any impact with patch cords. But as you get up to 60 degrees Celsius, you do see that, with a unscreened system of 75, you have a max link of 75 or 83 with screened. So again, per Panduit's internal testing, these are conservative values. So Panduit will be publishing information here on where we see it, but I can say that Panduit cables do not have the as restrictive of length D ratings. Another comment here is that a lot of people see this and they're somewhat concerned that says, this seems a lot to me. This information has been in the C.2 document for as long as it's been out. So, even though this, essentially new information people are not familiar with, I will say that this information's been out there. It's affected 5E, 6, and 6A cables, and we have had no reported instances ever where this has ever come into concern. So just keep that in mind with that out there, that this guidance has always been there. So whether or not you're installing cable in a hot area or whatnot, our own observations is that historically it hasn't been a problem. Going forward, our recommendation is to say we might need to just take this into account because the cables will be getting a little bit warmer. So now what I've done is I've taken the temperature rise per bundle size. And what I've been using here is I'm going to draw two different things together. I'm going to show what the model says, what Panduit's measured says, and then trying to pull this in with the table before to really help you guys understand what's going on here. So for different bundle sizes here on the left, you see that the cables get hotter. And you can see that, when you're comparing a 5E to 6 system, category 5E is getting significantly hotter. And when you compare 600 milliamps to 1,000, you see that the 1,000 milliamps, does seem to have a significant rise, particularly on the 5E. So when you're back down at around 600 milliamps, you see that a category 5E system is supposed to get up to about 8.1 C with a large bundle. The model says 6A is only about 5.3. What we've measured internally is only about a 1.2. So there's a very negligible impact on lower power PoE for heat rise with a 6A system. Now when you go up to a higher 1,000 milliamp system, you see that 5E is at about 22.6. The model says 6A should be about 14.8. What we've actually measured on a Panduit matrix system is 9.2. So what does that mean for you? 9.2 C could mean a loss of about 3 meters. And the way I got to that was 9 degrees is about, if you're at 20, you go up to 9, that's about 10. So you go from a 90-meter link to about 87. So that means that you're losing about 3 meters of your overall channel, and that's if your entire channel is at that temperature. That's something to remember here. So I've been asked the question before, well, what if I have 24 cable bundles or 48 cable bundles through most of the installation, but then I have a fire stop or some area where it's coming through a wall where I have to use these really, really big bundles? Do I need to worry about, the effect of that big bundle over the whole system, or is it just, impacting that region? And the answer is it's just impacting that region where it's occurring. So what I try to do is summarize it a different way. Is a loss of 3 meters over 100 or over 90 meters means only about 0.033 meters per meter bundled in 20 degrees C. So, the question is then, so if you have using 24 cable bundles and you have one area, you have a big cable bundled together, you're only going to lose, say it's 2 meters long, you're only going to lose about 0.06 meters of channel length, which, with a headroom warranty like Panduit has, that loss is completely insignificant. So the point to gather on all this is that you really need to look at where's the bundling occurring, how big is it at, and it's probably going to be insignificant if you're only doing large bundles in very concentrated locations. This is taking it a little bit further, just effective heat on channel length, and this is just looking at the loss per meter unscreened and the loss per meter screened at these different temperatures. So I already walked you guys through it. What you really see here is that, again, there's a very minimal impact on your overall channel length if if these temperature rises are only seen in very small locations. For example, again, different examples would be, most of your cable is running in trays or whatnot in the building, but then you go into some areas like by a ceiling where there's no air ventilation. It could get hot during the summer when the sun hits it. Or if you're going into a hot aisle in a data center, or it's hot in your TR room, it's very limited impact if the whole overall channel isn't experiencing it. And there's ways you can kind of use this information, to almost develop a model to say, okay, here's what my channel looks like. It's going through these different areas, and here's how to tie it all together to say, is there really a risk here or not at that length? So, pulling this all together, heat is governed by the ambient temperature, so hot is it outside or in your office, type of PoE used, cable category type and its implementation, and bundle size. So, pulling it all together, can you establish a relationship between bundle size and channel length? And what it shows here, right, is a lot of people always say, well, why do I install 6A over 5E? What does it really get me, right? You're saying that, category 6A doesn't get as hot, so what? And it really translates into loss, right? If something gets hotter, what I'm showing you is it does lose a little bit more per unit length. So when you put it all together, you see that a 6A system has about a 5-meter loss versus a 5E system due to the less temperature rise you get on that 6A system. So it's really why with a PoE, Panduit recommends installing category 6A. It provides the best thermal performance for that given case. 6A is needed for 10G base T. These new PoE standards allow for 10G base T. So by putting a category 6A system into your installation, you're really ensuring you're getting the best thermal performance, as well as ensuring that your installation has the bandwidth needed in case you ever do upgrade to that higher power or that higher speed stuff. Some ways to mitigate heat rise is to show, and this is taken out of the TSB 184 draft, is by separating your bundles. So take the one in the center where you've got 3 tightly packed bundles of 37, no separation. That would be at about 11.8 degree heat rise. Now, if that's a full 91 cable bundle, that's 25% higher at about 14.8. Now, if you've got 3 bundles with a 1-inch separation, that's about 30% lower, or about 8.3 degrees heat rise. So, just a few different ways where if you are concerned about it, if you make the bundles smaller and add a little bit of separation between them, it does help a lot. A common question that gets asked a lot here is, what is a bundle? A bundle refers to tightly packed cables. And I can't really give a better definition than that. I mean, we could, at TIA, I'm sure we could spend all day debating the definition, but it's really a group of tightly bundled cables. And that's significant because, these are bundles of cables where you can imagine I've got some sort of cable tie or hand tie wrapped around it, keeping them together. But then you've also got cable trays where you're starting to throw cables on top of each other and just lumping them together. That also can count provided they're tightly packed. If you've got a handful of cables laid in there, maybe 1, 2, 3 layers, and they're sort of loosely fitting in there, you're much closer to limiting the impact, right? As long as air can get to the cables, you're going to be okay. When you've got it so that everything's just jammed in there, I mean, you're really getting close to what looks like just your typical round cable bundle. So right now I don't have a better definition for you, but other than to say if the cables are packed together and you don't really think air is getting to those cables in the center, you've got a bundle on your hands. Last way to say Category 6A is more efficient, right? So 5E cables, they get hotter. Why do they get hotter? They generate more heat, meaning more power is lost, right? I mean, heat's coming from somewhere. Category 6A is more efficient. It has larger wires, therefore less heat is lost. I mean, typically a lot of 5E cables this day use 24 gauge wire. A 6A cable is 23 gauge wire. And even comparing 6A to 6, usually 6A cables use a larger 23 gauge wire than a Cat 6. So when you get down to it, for that same amount of cable, a Category 6A system will use about 4 watts less power. And the reason why is that when you look at it, right, the end device will get 71 watts. Remember I said it doesn't matter how long of a channel you use, what type of cable you use, as long as it's a compliant 5E or 6A system. The source is going to send as much power as needed to ensure that that power device gets that 71 watts it needs. So when you're using a 6A system, that power sourcing equipment doesn't need to send as much power out because not as much will be lost through the cable. The PSE and the PD talk to each other. For a 5E system, you will need to send out a little bit more power to ensure that that power device gets what it needs. So, summary of the PoE performance standards. Install 6A. 6A allows for larger bundle sizes. 6A can go for longer reaches with PoE. And Category 6A is more efficient on the power it transmits. All right, now we're going to talk about the impact of the new National Electric Code on cable. So, the impact of the 2017 code. It generally does not apply for power supplied over a communications cable when power levels are 60 watts or less. And what does it mean? If you recall, there are 2 types of PoE we are mentioning that are coming. There's Type 3 and Type 4. It is applicable for Type 4. It is not applicable for Type 3. What it means is that, with Type 3, that's your 60 watt at the power source, and that covers the vast majority of installations. Simple way to think of it is everything you got running for PoE now, that's 60 watts or less, because nothing else exists right now. So all that stuff you got running today, this does not impact, does not cover. However, for those highest power standards, it may cover, or it will cover. Recognizes a new UL listing for limited power or LP cables. To be clear about it, LP cables are not required to run PoE. However, if you do not have an LP listing, you will have to watch your bundle sizes per an ampacity table. And there is uncertainty about how inspections will work, meaning that, you put your cable in before you really are putting your equipment in. So you don't, if someone's coming in to inspect it and saying, well, this is going to be a Type 4 and this is a Type 3, nobody really knows, right? How do you know what goes where? Speculation, and this is only speculation, is that inspections may occur by application type, meaning where the cables are going might impact what LP rating, or if they need an LP rating or not. When will this apply to me? Well, it depends on where you're living. This isn't a presidential map or anything else. This is just, and I should check that this is up to date these days, but this was a listing of which states are adopting which National Electric Code. So the thing to remember about the National Electric Code, it is not national. It is adopted at a state and sometimes a local level. So you can see that many states are on the 2014 code, which when I created this was the most recent and up-to-date code available. figure there are a lot of those states that try to stay on the most recent code will adopt the 2017 code quicker than others. Other states that are in green or red are on older versions of the code, red being all the way back to 2008, green being on 2011. States that are shown in yellow have a local adoption. You know, I'm from the state of Illinois. The way the code is enforced or the way the code applies can vary depending on where you are in the state. So it's very difficult to give a universal answer here on how this code will be applied for anyone on this call. You know, again, we have our speculations on how it could be done, but it's always going to vary. You know, it's going to vary and be open to interpretation depending on, you know, who's doing the inspecting, who's writing, you know, the specific rules for your region. So unfortunately, I can't give any better information than that right now. So again, this is just breaking it down. One more way to show it is that with PoE++, you know, the two new standards at the bottom, if you're above the line, the 2017 NEC is not a concern. If it's below that line, you have these new requirements. So if the requirements apply, you are running Type 4 PoE++. So either you must use an LP listed cable rated to at least 0.5 amps, or you have to refer to an ampacity table for bundle size. And this bundle size given by the ampacity table will depend on cable temperature rating, wire gauge, and how hot it is, your ambient temperature. With an LP cable, an LP means limited power, there's going to be a marking on the cable. This is a test, this is a UL test all cable vendors would have to go through. And you would see it on the jacket. So right now, you know, you'd see here, before it would say type CMP, UL, 23 gauge, 90C. Now you're going to have type CMP -LP, in parentheses will be the amps per wire, and then it'll go on as normal. So you might be saying, well, why is it 0.5 amps? I thought the new standard was about up to 1 amp. Because you take that value is per wire. So when I say 1 amp, that's per pair. The amps run on both pairs, so you divide by 2, it's a ½ amp per wire. And 0.5 amp covers Type 4 up to 100 watts. So if you have a higher rated LP rating, such as 0.7 amps, that allows up to 140 watts. There's no known application for higher LP ratings, but you know, the general understanding would be that a higher rated LP cable would have better thermal performance and better PoE performance overall. It really means that when the testing was run, right, it's really, the test is looking at, can the cable for a larger bundle size handle the temperature up to its given temperature rating. So it means that a 0.5 amp cable can handle the 0.5 amps current and is within its temperature rating. A 0.7 amp cable, it was able to handle the 1.4 watts and still was able to maintain its the temperature rise state under the cable's temperature rating. So again, just indicative that it's a better performing cable. Here's an example of the ampacity table. This is taken out of the code. And what you can see here is that on the left, it says wire gauge. All right, 26, 24, 23, 22. Then you have 1, 2 to 7, 8 to 19, 20 to 37, et cetera, up to 92 to 192. That refers to bundle size. Then under that, you see temperature rating, and then you have 60, 75, 90. That refers to your cable's operating temperature rating. So a way to look at this is that most cables that we use today, say a 5E, 6, or 6A cable, are 24 or 23 gauge. And then typically most cables are 60 or 75. So a lot of new cables, I know Panduit does offer 90-degree rated cables as well. So 90 degree is becoming more common. And what you see then is this number down here. This is your ampacity. This would be your LP rating or ampacity rating. So for some commonly rated cables, like a 23 gauge, which is a lot of Cat 6 cables, at 62 degrees C cable rating, could have a bundle of up to 91 cables. A 23 gauge cable with a 75 degree rating could have up to 192 cables. So again, this isn't a very restrictive, right? 23 gauge, 75 degree cable could pretty commonly is a pretty common cable, and 192 bundles isn't very restrictive. However, right, just thinking it through, you're going to have to validate that if you have some large bundles, you're falling within that 192 range. Now, a common Cat 5e cable would be a 24 gauge type of cable, and you can see that with a Category 5e, if it's a 60 degree rated cable, your bundle is going to be limited to 61 cables, and for 75, your bundle is going to be at 91. So you can see that, right, this does have an impact. And everything we're telling you with, TIA and on the performance side, that's important for getting your network to run. And if, we're providing guidance on it, but if you're not meeting our guidance, you should still be passing data. And as long as everything's working, you're all good. What we're telling you here is, code compliance. So these are the rules you absolutely have to follow if people are enforcing that code. So, summary of the 2017 NEC only applies for greater than 60 watts, the new Type 4. There's a new UL listing for LP cables. You will need an LP rating of at least 0.5 amps or higher, and without LP, refer to the ampacity table. So now I'm going to try to give you a recommendation for putting it all together. So really here, right, we've had two different documents discussing bundling size. You have performance from TSB 184A and some of it from 568C.2. And then you also have the NEC ampacity table for non-LP cables. So what do you do? So first, what do you need to know? What's the ambient temperature? What's the length of the channel? And is the cable LP rated? And if it's not LP rated, what is the cable temperature rating and wire gauge? And what this determines is your max bundle size. So this example I'll show is that, okay, you need a 92 meter channel and you're not using an LP cable. And a few information about it is you're running this Type 4 PoE, cable is 60 degree rated, ambience 30, cable is 23 gauge, and it's 6A, not LP rated. So with that information, the National Electric Code limits you to 91 cables, referring to the ampacity. And then if you try to reference all this with TIA, is that if you want to go 92 meters, the channel D rating of 8 meters occurs with a cable temperature of 45 degrees C. 45 degrees C implies a 15 degree bundle temperature rise over ambient, right? So you're saying it's 30 degrees C and you're getting a 15 degree temperature rise from your cable. And per the model, it says that your cable bundle can be greater than 91 cables for a 15 degree temperature rise. And per actual test data, you can actually be above 100 cables. So the bundle size limit you're really going to run into here is you've got to stay within 91 cables per the National Electric Code. Now, if all you're seeing is, if all you've changed here now is you're using an LP cable, what we've seen here now is that the shifts, right? LP now means you don't have to really worry about your bundle size per the National Electric Code, but now you should be more concerned about what's the impact of performance. And for performance, depending on what you're looking at, is you can either be greater than 91 cables per TSB, or per actual test data, you can go even bigger than that with using 6A. So now your bundle size limit shifts from the NEC to being concerned on performance. So you can actually go a little bit bigger when using the LP cables. Now, if you've got a 92 meter channel with Cat 5e LP cables, again, because it's an LP rated cable, you don't have to be as concerned about the cable, the bundle size limits related to the NEC. But now, per ANSI TIA, you have to worry about this 8-meter temperature, or this 8-meter derating with 45 degrees Celsius. Now, per TSB 184A, it says that you have to have 61 cables or less for a 15-degree temperature rise, right? Because this 8 meters is occurring, the cable temperature of 45 degrees C, we're saying the ambient's 30, so 30 plus your 15-degree temperature rise is 45. And 61 cables gets you to that 15-degree temperature rise. So now, if you're using a 5E cable to run that, you're going to be limited to about 61 cables. So 5E does have worse performance. Our recommendation is to install Category 6A. So in summary here, LP is shifting your bundle size restriction to TSB 184A. So if you have an LP rated cable, what this means is your major concern here is going to be performance. Without LP, you need to refer to both TSB 184A and the ampacity table to understand bundle size. You will now need to know what your ambient temperature is and how hot your bundles get. And if you can see anything through all these examples here, Category 6A does have the best performance. So that really ends the this portion of the presentation. Now I believe we're going to go through some of the questions that were asked while I was speaking. So, Sandy?
Sure. Thanks, Frank. Let's start off with what makes LP cable different from a non-LP cable? Is there a different construction?
Not necessarily. There may or may not be. I mean, what we've been seeing is that typically LP cables have a higher temperature rating than non-LP cables. 90 degree for an LP cable is common. So you need to ensure all the cables, or all the, your cable construction can handle that 90 degrees rated cable. I mean, I know that Panduit and General Cable both offer a lot of LP rated cables. So you'll see that especially on a Cat 6, where you might use a more of FEP construction, meaning the way you're doing your pairs is a little different. We've seen on 6A it's a little bit easier to meet LP ratings, especially when you have a matrix technology or using the foil, like Panduit in general does on our 6A cables. So with 6A we found really we didn't need to make any major tweaks to the design, but sometimes you know, it's a little bit more challenging on a lower category to meet it.
Okay. Are you aware of any discussion in regards to similar electrical code requirements by the CEC or CSA?
Personally, I'm not aware of any. I would speculate. I mean, we've kind of seen what's playing out here in the United States has a potential to, you know, play out elsewhere because there's a lot of different interested parties. But no, I'm not specifically aware of anything.
And I hope I get this question correct. Somebody's asking for your comments about various cable types for different applications that are running in the same cable pathway or space. Is there anything that installers need to be aware of if they're installing?
Not, you know, if you're following typical installation practices, you know, really when you get down to what the implications are here is that you'll be fine. The only time that this should really be of a concern to a lot of people is if you're really getting closer to that 100-meter cable limit and you think that a high percentage of your cables will be running PoE. What we've seen is that typically, you know, in a big bundle of cable today, maybe 30, 40, I mean at most 50% of your cables will be running PoE. That might change in the future as maybe a higher percentage start running it, but in practice, you know, we've seen there being very minimal impact on really anything, you know, with PoE negatively impacting the performance. So, you know, when you get down to following installation practices, the only time this should be a concern is when you're getting much closer to that 100-meter limit, and then there's a variety of ways to just mitigated, whether you look at, bundle sizes or how many cables you're throwing in a tray, or maybe, those cables that, because if you're throwing a bunch of cables in the tray, not all of them are probably running to that 100-meter limit. You might be having a small fraction of those. So is there ways you can handle that? We're still working on to provide guidance there, but we're planning on having a lot more information coming soon on really providing good guidance for design on PoE.
Do different cable constructions perform differently for PoE?
Absolutely. I think a lot of what we talked about here is that we found 6A cables tend to perform better, and there's two reasons for that. The first reason is that the 6A cables do have a slightly bigger wire gauge, because even if 5E cables tend to be 24, Cat 6 are 23 usually, 6A are slightly bigger, 23, and that helps with the heat dissipation. The other reason, though, is a lot of 6A cables, like Panduit or General's cables, we use like the matrix or mosaic technology. And what that is that's a discontinuous metallic foil that wraps around the cable. And that was really put in there initially to help with alien crosstalk, or the talking between the cables. But it actually had a nice benefit, because as you're wrapping the cable with metal, essentially, metal is a good conductor of heat. If you think about a metal frying pan, right? If you heat up that metal frying pan and you touch it, it'll burn you. And it conducts heat very well. If you pick it up with the oven mitt, you're okay. So because these cables have this metal wrapping around them, you imagine a big grouping or bundle of them, the heat from those cables on the inside is able to dissipate outward better, and that's another reason why you see a difference between a Cat 6A and a Cat 6 23 gauge cable.
On what you've been talking about here, is this terminated on standard patch panels and jacks?
Yes. Really, there's, standard patch cords and jacks work great. I mean, we've had no issues on it, and all testing that has been done here has been using Panduit's standard jacks and patch cords.
That kind of leads into additional question on connectors. Is there anything related to connectors that you need to be aware of with PoE? You've talked a lot about cable. What about the connector end of it?
Yeah, so there is a little bit to be aware of with connectors. There's a test out there. It's a 60512-9, I believe, -001. And what it looks at is as you're taking the plug and inserting it and removing it from a connector, you can have an issue where, or there is an issue where there's a little sparking that occurs. I have a graphic, and I believe one of the handouts there goes over this in much greater detail if anyone's concerned on it. And what it shows is that PoE is a live circuit once it's activated. So when you're putting the plug in, it's not active until it does a handshake. But then when it's plugged in and everything turns on, it's active. So when you're pulling the plug out, it's basically like you're unplugging a live circuit. There's some arcing that occurs between the plug and the jack contacts. And there's a carbon buildup that can occur related to that electrical arcing. And that, you can have an issue if that arcing occurs at the location where the plug and the jack have their final mating point, and there's nothing in the plug or jack design that really helps, scrape away that. Sometimes we know when you're putting a plug into a jack and it provides a little resistance, that resistance is good because it's really cleaning that mating point. You can have a loss of connection between the two if you've had multiple cycles. And so there are now ways to get third-party certifications showing that your jack is compliant for PoE related to that test. So Panduit does provide third-party certifications of our test, and our jacks are still rated up to about 2,500 cycles with PoE with this live plugging and unplugging. So.
All right. Are there any concerns using small diameter patch like 28 gauge with PoE?
No, 28 gauge performs fine with PoE. There's, Panduit has sold millions of our 28 gauge patch cables, and many of those patch cables are today running PoE. So there's absolutely no concerns to be had with 28 gauge. The only item to be aware of is bundle size. So Panduit does have some guidance on our I believe in some of these documents even on how to limit your bundle sizes with 28 gauge if you believe all the cables are to be running this this new highest power PoE. I think we recommend keeping the bundle size to 24 cables or less. But overall, right, the way Panduit certifies these cables is that we put these cables in a channel, and we run the channel, and we test that channel to ensure that it still meets all those requirements. So, you know, when you're using a 20 gauge patch cable, that is still a compliant Category 6, Category 6A channel. And for PoE, you need to be ensured that that's a compliant channel. And our cables and other people's, other reputable vendors that sell these cables, we can tell you that it's still a compliant PoE channel because it's still meeting those same requirements.
Okay, great. One more question here. Somebody has typed in, I'm running PoE through a fire stop with a large bundle of cables, which I think that you gave an example of this earlier as you were talking. Bundled together for 5 to 10 feet. Does this affect my channel length?
Yeah, we did cover this a little bit, and really to answer that question is it has a very minimal impact. Typically, right, you might have 24, 48 cable bundles leading into this big wad of cables, right? So for that big wad of cables, you only need to be concerned with the impact over that, say, 5 to 10 feet, so that 2 to 3 meter range. And I think the example we showed was that the impact of those higher bundle sizes, you know, with this higher power is only about 0.03, 0.04 meters lost per meter bundle. So when you're saying you've got about 3 meters of cable together, you're only going to lose about just over 0.1 meters in total channel length, which when you buy, you know, you look at a system like, you know, most vendors, like I know Panduit offers headroom warranty on our insertion loss, which means that, you know, we offer margin above the standard. And so when you look at what's the impact of a 0.1 meter, you know, potential loss versus the headroom you offer, you're nowhere near it. So, you know, yes, there's about a minor impact of about a 0.1 meter loss, but on top of everything, it's really almost a no impact on your overall channel length, practically. So.
All right. Well, I think that takes care of the questions that have come in. Want to thank Frank for sharing his time and his insights with us today. Want to remind you that as soon as we end the presentation, a survey will pop up. If you want your VIXI continuing education credits, that's where you will put in your email address so that we can take care of that for you. And again, we would appreciate you going ahead and filling out that survey for us for some additional insights around this subject. So again, thanks to Frank, and thanks to all of you for attending and on the direction that PoE is headed.
Thank you, everyone.